Hi there guys, and welcome to this video on circles. It's going to be our last one. It's when it starts to get pretty tricky, so make sure you pay attention, pause the video when you need to, just to take it all in, and maybe even try and get ahead and have a go at the question first. Alright, so I would always say make a sketch of your drawing. Really think about your sketch. It's not something that you should rush. I don't use a ruler or whatever, but in this instance they've drawn it for us, which is really kind. Now the first two sentences just tell us what we can already see, but then this is where it starts to get important here. So M is the midpoint. Okay, so that tells me a lot about this line segment. It's a midpoint. And you can see that this line here that they're calling L, which is what we have to find the equation for, actually passes through this midpoint. Now there's a circle theorem that is not widely taught at GCSE. So if you take a chord and you draw a perpendicular bisector, that was the worst line I've ever drawn in my life. So there we go. What I mean by perpendicular bisector, if you bisect something, you cut it exactly in half, it will always go through the origin. So what that tells me are these are 90 degrees to each other. They're perpendicular. So that's really important. So I could, on here, on my notation, I could put, like, say, I'll do two lines so it looks a bit easier. So they are equal in length. That's why it's a midpoint. And there we have it. Okay, this is a circle then. This is going to open up this question. Without that knowledge, it's very difficult to start. So we've got to find the equation of this line L. And to do that, we need to know y equals mx plus c. All we need to find out is m and c, and at the moment we've got neither. But because we know it's 90 degrees, it's perpendicular to this line PQ, that seems a sensible place to start. Let's find the gradient of PQ. So let's write the formula, y2 minus y1, change in y, over the change in x. And I'm going to go left to right, so I'm going to go minus 1 minus 5 over minus 7 minus 3. So what is that? Minus 1 plus 5, well, that's got to be a 4 over minus 10, which is minus 2 over 5. Lots of people keep the minus as a denominator. That's really naff. A positive divided by a negative is a negative, so put that in front. Okay, so we are now at this position. So that is the gradient of PQ, so the gradient of our line L must be 5 over 2. So we're getting a bit closer. So what we need to find this equation, we just need a line on this equation, and M seems to be the easiest option. So M is the midpoint, so just find the average of the x's. So we're going to add minus 7 and 3 and find the average. There's two of them, so divide by 2. Minus 1, add negative 5, and again find the average of two numbers. So what does that mean? Minus 4 divided by 2, well, that's minus 2. Minus 6 divided by 2 is minus 3. Check that in your drawing. Just, so many people write an answer here. You always get an answer, won't you? And you look at the drawing and you go, well, that wasn't right. If they're like, for example, if that was positive, if it's up there. So just check your drawings, because you don't want to get too far into these questions and realise you have to start again. Okay, so here we are at this point. So we've got three unknowns. So to find an unknown, you've got to sub in for two of them, and we've got x and a y right here. So let's pop these in. So minus 3 equals 5 over 2, lots of minus 2, plus c. So quite often I would times by this denominator to get rid of it, but actually these are going to cancel. So this is, when I say cancel, it's going to be a minus 1. 2 divided by 2 is 1. So I end up with minus 3 is minus 5 plus c. So that means c is 2. So we've got an equation for y equals 5 over 2x plus 2. So a positive gradient, that's what we're expecting. We've got a y-intercept of 2. That looks good for the drawing. And if they ever ask you to write it in the form ax plus by plus c equals 0, what that means is we don't want any non-integer values. So I'm going to do this as well. I'm going to times everything by, it doesn't ask you to do this in the question, but I'm just going to do it. times everything by 2, and then get everything on one side. So 5x minus 2y plus 4. It's much easier for substituting in, and we'll probably have to do that later on. So I would always write it in this form. It's a good habit. I've kind of run out of paper, so I'm going to just see if I can shrink. Oops, didn't want to do that. Let's go from the bottom. Okay, it's not going to let me do it, but so I'm going to just shrink the whole thing, guys. That's so annoying. I'm just going to get rid of that. Okay, so hopefully you can still read this. Oh. Okay, so part B. So we're told that the y coordinate of C, so we don't know what the x is, but we know the y coordinate is minus 8. I would just show that. You've got to love a show that, because if you do show that, you know it's right, and you also know that all of A is right as well. So show that this x coordinate here is minus 4. Well, to show that a coordinate is a certain value, you need to know the equation of the line, which we do. And I'm actually going to use the ax plus by plus c version. So I'm just going to sub in my minus 8, and hopefully when I rearrange everything, I will get minus 4. And if I don't, I'm going to quickly pause this and change it. So let's have a look. So we've got 5x plus 16 plus 4 is 20. Here we go. So minus 20 is equal to 5x. X is equal to minus 4. So therefore it's shown. So this is part B here. C, let's find the equation of the circle. That's pretty easy because we've got the centre. So we know at the moment it's x plus 4 to get that transformation left. We've got a transformation down of 8, so we know it's y plus 8, and all we have to find is what r squared is, which is just a Pythagoras problem, length between two coordinates. So I'm going to use this one and this one. So r squared. Now it's easy actually to find what r is here using Pythagoras' theorem, but then you have to square it. So if you just treat this as a hypotenuse, I'll just draw it actually. So this is C, this is Q, this is R, this is what we're trying to find. But we know that R squared is equal to this length squared. And if you look at the change in X between 3 and minus 4, that's 7. And if you look at the change in Y between minus 5 and minus 8, that's 3. So we know that R squared is 3 squared plus 7 squared, which is 58. So to finish off, it's x plus 4 squared plus y plus 8 squared equals 58. Okay, hopefully that's made sense to you. Let's look at another one. OKeydoke. So I can see here there's a mention of tangent. So in my head, I haven't read this question yet, but in my head I can see the word tangent, and I've got b squared minus 4ac equals 0 going off. I might not have to use it, but we'll see how this question goes. Okay, so we've got a circle without a drawing, or graph I should say, without a drawing, so let's draw it. So we've got a 5 minus 3 centre. The radius is 10, so that's a little bit over 3. So this value here is 3, so I'm going to make sure my circle crosses it. It's not a very good circle, but it's good working. Now we've got a line L as a tangent to the circle, and it has a gradient of minus 3. So this is where you've got to be a little bit careful. My drawing could be really inaccurate here. For example, if I draw it like this, that's my attempt at a tangent. I'll draw another one up here. They're the two, by the way, the two possible ones. They're just parallel to each other. So mine looks like I've got a 0 y-intercept here, but that could have easily been negative, or it could have been much steeper and been positive. So I've just got to be a bit of leeway with my drawing. If I get a positive value up here and another positive one, that could be fine. Or if I've got a negative one and a positive one, that could be fine. We'll see how it goes. but don't think it has to be in that quadrant, because it's just a sketch. Okay, so what should I do here? Normally I would just think about subbing this in. So what do we know about these tangents? At the moment we know it's y equals minus 3x plus c. So we could maybe sub this in to here. That's what we would normally do, so let's go for that. X minus 5 squared plus... Okay, right. I don't want to expand a 3-term bracket. It's got to be a better way. I'm just going to cross that out. Now, what I'm thinking of, and I've just seen it, is always go back to your circle theorems. Like the first one was a circle theorem question. This is also a circle theorem. So if we have a tangent, and we actually know this center point, if I was to draw that, I know that's 90. And if I was to do the same on this side, I know that's 90. So it's going from one side to the other through the center. I know I have a diameter now. Now, why is that useful? Let's just pop this on, because the more on my diagram, the easier it is for me to see it. That's a minus 3 there. Well, I know the gradient of this orange line. Because the gradient of the pink line is minus 3, the gradient of the orange line is 1/3. So at the moment I know it's y equals 1/3 of x plus c. And looking at my picture, I have a coordinate on that line, so I can actually work out the equation of that line, which would be really helpful because then I can solve them simultaneously without this complicated bit here that I just crossed out. So let's pop that in. So minus 3 equals 1/3 of 5 plus c. Now that's not a friendly calculation, so I'm going to times everything by 3. Now a lot of people forget to times the c by 3, but just make sure you do that. So 3c is minus 14, so c is minus 14 over 3. Right, so let's just solve them simultaneously now. So we've got y equals 1/3 x minus 14 over 3. So not nice numbers. I was just pausing there because I was thinking, shall I multiply all this out? But I'm subbing it in for y, not 3y, so I'm just going to leave it as it is. So I'll just see if I can, I'll tell you what, let me just get rid of that because that's naff. See if I can just shrink this bit a little bit. There we go. Shove it over here. Right, so this should be enough room. So x minus 5 squared plus, so we've got 1/3 x, I'm going to write it as x over 3, minus 14 over 3. Now instead of writing plus 3, what I like to do is make it a fraction so I can collect my denominators really fast, is equal to 10. So I've got x minus 5 all squared plus x over 3 minus 5 over 3, so that's a 3, sorry, equals 10. So not the nicest bracket to expand, but it's the only way we're going to get this question done. So we've got x squared minus 10x plus 25. Now we have to take our time. X over 3 squared, well, that's x squared over 9. If you think about the outers, we're going to be multiplying these two together, so we have minus 5x over 9. But the inners will be the same, so it'll be minus 10x over 9. And then 25 over 9, and that's equal to 10. Okay, let's collect like terms. So I could times everything by 9 now. Should I do that? No, I'm just going to collect the like terms. So if I think of a whole one as 9 over 9, I've got 10 x squared over 9. This one would be 90, so I've got minus 90, take away another 10, so I've got minus 100 x over 9. What's 25 times 9? 225, so that's another 250 over 9. Now I'm going to times by 10, they're really annoying me now. So 10x squared minus 100x's plus 250 equals 90. If when you're watching this you think of an easier way, just pop it on Teams. I'd like to see it, but this is the way I've done it. They're all in the tens. Let's just divide by 10. Why not? It's definitely going to make my life a bit easier. Oh, and let's bring this over at the same time. So what is that? 16? I think that's right. Yeah. Okay, factorise it, factorises, so surely it is right. So I've got two values. I've got one at 2 and one as 8. Which means I suggest that this value here is the 8 and this value here is the 2. So to find the equations of the lines, I am going to need to keep going. I need to know the y coordinate for this, and I need to sub it in to find out what the y-intercepts are. So we've still got a bit to go. Right, I'm going to just write down the equation of the circle again because I can't see it anymore. What was it? Plus 3. Oh. I can't see an easier equation for us to use to find the y values, so I'm just going to find that one. Oh, I could use this one. I could use this one because they're also on that line. So take your pick. I've written this one now, so I'm going to use it. So what's 2 take away 5? That's minus 3. Minus 3 squared is 9. So I've got 9 plus y plus 3 squared, and that's equal to 10. I'm not going to expand that because I can solve it like I'm completing the square here. So we get y plus 3 squared is equal to 1. So y plus 3 is equal to the square root of 1, which is plus or minus 1. And then y would be minus 4 plus or minus 1. Now, I don't want to use the squared one because it's going to give me that. That's going to really annoy me. So, sorry, get rid of that. I probably could have just taken one of them, but let's use this one. So, y is equal to a third x minus 14 over 3, which is the same as 3y is equal to x minus 14. We're going to have much easier time with this one. So, when x is 2, 3y is minus 12, so y is minus 4. See, much easier to sub in this form than that form. When x is 8, 3y, 8 take away 14 is minus 6, y is minus 2. Okay, so let's just check those out. So we've got 8 minus 2, that looks pretty good in my drawing. We've got 2 minus 4, yeah, that works as well. So I'm pretty happy with my answers. Right, so let's find the equation. So we have y equals 3x plus c. This feels like it's going on forever, doesn't it? We've got these values we can sub in, 3 lots of 2 plus c. So minus 4 equals 6 plus c. So c is minus 10. Just finish this one off. So we've got y equals 3x minus 10. You can see my sketch had it going through the origin, so it was really wrong. Let's do this one as well. So minus 2 is 3 lots of 8 plus c. Minus 2 is 24 plus c. So c is minus 26. So wow, my sketch was really wrong. Okay, so guys, there you have it. Oh wait, I've just realised what I've done. Absolute plonker, it's minus 3, isn't it? So that's a minus, that's a minus, that's a minus, that's a minus, that's a minus. So we actually get 22 there. Right, now that sits better with me. Right. So what's that going to be? That's going to be a 2. Okay, so yeah, there we go. Sorry about that. I wasn't happy with that, and just spotted it. You were probably shouting at the screen, "That's a minus 2, you idiot." There you go. You were right. Okay, pretty big questions. I will just go back to that first circle theorem again, because if you have a chord and you perpendicularly bisect it, It will cross the centre at some point, so we're not too sure where it is. But if you have another chord and you do exactly the same, again that line will hit the centre, but you're just not sure where. But if two at the same time, where those two bisector lines meet, will always be the centre. So useful fact, you may need to use that for the questions. Alright, best of luck everyone.